Okay, Unit 6, Part 2 says the path of a model rocket launched from the ground is parabolic. Crews built a reusable model rocket using a kit. After launching it a few times from ground level, that's a little hint right there, launches it from ground level, crews determined that the rocket could reach a maximum height of 400 feet after traveling a horizontal distance of 15 feet. On the flight where it reached the maximum height, the rocket landed 30 feet away from the launch site. So let's color code these. So we have ground level. We had maximum height of 400 feet after traveling 15 feet, and then landed 30 feet away from the launch site. Cruz's friends asked him to launch the rocket again in an area with several trees. He's worried that the rocket will be destroyed if the trees block the path, especially since a 115-foot tall pine tree stands 2 feet from the landing spot. So we're looking at this one as well. Right. This one has a coordinate, the tree, as well. So let's start figuring out where these are, what these points are. So if we're looking at this ground level, it looks like this here is at the origin. In the origin, if it is ground level, you're 0 feet up in the air. Right, this is feet. And this is horizontal feet. Let me see if I can move this. Okay, so now let's put these points in. So this is the origin. It started ground level. That's 0, 0. Let's look at our vertex. So vertex is the maximum or minimum. When we have that terminology, we know that we get our maximum there. So after traveling a distance of 15 feet, it is 400 feet up in the air. Okay, next piece of information, I'm going to do this x-intercept here. It says the rocket landed 30 feet away from the launch site. So here's my 30 feet. And if it lands on the ground, it's back at 0 feet up in the air. Now this last piece here where that other coordinate is, this one's going to be a little bit tricky. So this tree stands 2 feet from the landing spot. So 2 feet from the landing spot, it lands right here at 30. 2 feet away from that would be 28, right? 2 feet away, so 28, 29, 30. And it's 115 feet tall. Okay, so there we have all our coordinates, and always check to see if you have it correct. If this is 30, you start at 0. Remember that to find your vertex, you do 0 plus 30 divided by 2. 0 plus 30 is 30, divided by 2 is 15. And your vertex should be at the x value of 15. Okay, so always double check to see if you have all these coordinates correct in the right place. X is where the x belongs, y is where the y belongs. Okay, so now let's go on to answering our questions. Write an equation of the rocket's path in the following. So vertex form. Hopefully you guys have this memorized, or at least know where to look for it by now. X minus h squared plus k. So vertex form, remember that we need the vertex for vertex form. So let's go ahead and write the vertex down. So for the vertex, we're looking at 15, 400. And we'll also need a additional point. So for an additional point, I get to pick any one of these points up here. I'm going to pick 0, 0 because that's going to be the easiest to work with. 0, 0. So now if I label this is my h, this is my k, this is my x, this is my y. Remember, vertex and vertex form, h and k are the vertex. So let's start plugging in. My y is 0 equals a times my x is 0 minus my h is 15 squared plus my k is 400. Right, and I just transferred all these over into their right spots. So now let's simplify. We get 0 equals a times 0 minus 15 is negative 15, and then negative 15 squared is 225 plus 400. So now let's subtract 400 on both sides. And we're left with 400, negative 400 equals a times 225. And then finally, divide by 225 on both sides. And we get that a equals, let's see, 400, negative 400 divided by 225, negative 1.7 forever. Okay. Now we can rewrite our equation. So what we need is our vertex and our a to rewrite this. So we'll have y equals, our a is negative 1.7 forever, times x minus 15 squared plus 400. And that is our equation in vertex form. Now let's go ahead and see what factored form would look like. In factored form, remember that it gives us two x-intercepts. Right? Vertex form gives us vertex form gives us vertex, factored form, or intercept form gives us two x-intercepts. So intercept form, remember that it is y equals a times x minus p times x minus q. So now let's start plugging in. Let's refer back and get our two x-intercepts. So we're looking at 0, 0, and 30, 0, and we're going to need an additional point. I'm going to use 15, 400. So for now, x-intercepts we know is 0. Sorry, our two x-intercepts, we're at x equals 0. So I'm going to write that. Let me erase these so it doesn't get in our way. It doesn't get confusing. Dang it. Okay, so we have one x-intercept at 0 and the other x-intercept at 30. Now remember that we need to write this so it is in parenthesis form. So we're going to subtract the 30 back to the other side, and we get x minus 30 for parenthesis. So that's our x minus p and our x minus q. At the same time, we're going to go ahead and write our x and y, and we take that from the vertex, and the vertex was 15, 400. So now if I plug these in, my y is 400 equals a times x plus 0. At this point, you could just leave that x. You don't have to make it x plus 0, but for the sake of consistency. And then one thing I didn't do here, replace our x's with 15. Because my x was 15 and my y was 400. So now simplifying all this, we get 400 equals a times 15 times negative 15. And I think you'll notice in this step that it's pretty similar to the one up above. Times negative 225, divide by negative 225, divide by negative 225, and we get that a equals negative 1.7, which is the same thing we got above. So now when we go to rewrite this, remember that we want to rewrite it in factored form. So we'll have y equals, we're going to plug in a, negative 1.7 forever, times x minus p was x plus 0, and then x minus q was x minus 30. And there is our equation. Okay, now for that last question there. It says, will Cruz's rocket make it over the pine tree? So remember, the pine tree is at 28 and it's at 115 up above. So if we plug in 28, if our rocket is above 115 feet, it'll make it. If it's below, it'll end up hitting the tree. So let's go and plug this in. So let's plug in 28 and see what we get. And you can choose either one of these to plug it into. I'm going to choose to plug x into the factored form. So we have y equals negative 1.7 forever times, for x we're plugging in 28, and then 28 minus 30, and let's simplify. You get y equals negative 1.7 forever times 28 times negative 30. Let's see, negative 30 times 28 gives us negative 840. So y equals negative 1.7 forever times negative 840. And now in my calculator, I'm going to put my negative 1.7, and what I'm going to do, since it's forever, I'm going to put negative 1 point and then a whole bunch of sevens, 7, 7, 7, 7, 7, until my calculator won't let me anymore, times negative 840. Let me do that one more time. 840 times 1. And we get that y equals 1,493.3 feet. So now if you look at this, the y value is at 1,000. If we go and we check to see if it'll clear it, oh, something's not right there. Let's go back and check this. Hold on a second. Okay, we had negative 1.7 forever times 28 times negative 2. Oh, I may have put the wrong. Let's see what the mistake was. I left this negative 30. This should have been negative 2, which would make this, sorry about this, okay, so then 28 times negative 2 is negative 56, and then negative 56 times that one, negative 1.777777777 is 99.55 feet. Okay, that makes more sense. So at 28 we get 99.55 feet. If we look at this coordinate, at 28 we're going up 99.5. So this parabola, I know it's drawn wrong, but it ends up going through the tree, which means that it will hit the tree. The parabola, the rocket is too low. It's underneath the tree at 28 horizontal feet, so it ends up hitting the tree, so it will not make it.